All right, folks, it happened, and it happened earlier than expected. On December 18th, we got hit by a geomagnetic storm that completely caught the forecasters off guard, and the best part? Montana and Washington got a light show that's usually reserved for Canada and Alaska. Stick around because what the sun is doing right now is absolutely fascinating. Okay, let's look at the data. On December 18th at 00 UTC, the KP index reached 5 lengths, that's officially G1 minor storm level. The trigger? A massive coronal hole. And when I say massive, I mean massive. This thing is U-shaped and stretches from the sun's north pole, across the equator, all the way deep into the southern hemisphere. You see these dark areas here? Those are coronal holes numbered 07 and 08. And from these holes, high-speed solar wind is shooting into space at speeds of up to 700 kilometers per second, heading straight for us. But here's where it gets interesting. NOAA had predicted this storm for later. Instead, it arrived several hours early. Why? Because this solar wind stream was faster than expected. This just shows you again, the sun doesn't keep to our schedules. The result? Aurora visible in Montana and Washington. That's pretty far south for normal conditions, folks. We're talking about latitudes where you'd normally need a KP of 6 or 7, but with this constellation, strong solar wind, plus a favorable BZ value, it was enough. Write in the comments, did any of you see the aurora and from which region? For the tech nerds among you, the interplanetary magnetic field value IMF was around 8 NAT. Interestingly, the BZ was pointing northward when the solar wind arrived on the 16th of December, unfavorable for auroras. But then, on the 18th, it turned southward, and boom, connection with our magnetic field. Energy flows in. Geomagnetic storm. Solar wind speed increased from 440 km/s to a peak of 615 km/s. That's not extreme, but definitely enough to give our magnetic field a good shake. The KP index fluctuated between 2 and 5 dians, classic G1 behavior. For comparison, in a G5 superstorm like the Carrington event, we'd see KP 9. What does this mean for technology? With G1 storms, we're talking about slight GPS inaccuracies, minimal high-frequency radio disruption, increased satellite drag. Satellites experience more atmospheric resistance. Nothing dramatic, but definitely measurable. Power grids remain completely unaffected at G1. For that, we'd need at least G3 and up. By the way, if you want to learn more about the G-scale, I've made a complete video about it, link in the description. And now comes the exciting question, what happens next? The forecast says December 21st, quiet KP2. December 22nd, possible G1 storm from a new solar wind stream. December 23rd, 26th, KP5 predicted minus, we could get Christmas auroras. The coronal hole is currently rotating out of our view, but there are already signs of new active regions on the eastern limb. AR4288, an old friend, seems to be coming back. That one caused quite a bit of action 2 weeks ago. Let's see if it still has energy. So folks, keep your Aurora apps ready. The sun is currently in the declining phase of solar cycle 25, but as you can see, it's not getting boring. Subscribe to the channel for daily space weather updates, hit the bell so you don't miss any storms, and write in the comments which space weather event do you want explained next. Until the next solar storm, stay safe and keep watching the skies.